10 is about solving systems of equations by graphing. The objective is to be able to solve a system by graphing. I have two examples. The first one is going to be 3. Hold on one second. Okay, the first example is going to be 3x minus 2y equals -6, and x plus y equals -2. So from here, the first step is going to be to put them into slope-intercept to make it easier to graph. So to do that, you have to isolate y on one side. So on the first one, we're going to subtract 3, and then we're going to end up with -2y equals -3x minus 6. And then we have to divide that by -2 to get the y by itself, and divide this side by -2. And then we're going to get y on this side, and 3 over 2 x over plus 3, because -6 divided by -2 is 3. So, and -3 divided by -2 is going to be positive 3 over 2x. And to put the other part of the system in slope-intercept form, we have x plus y equals -2, and I get the y by itself. So we're going to subtract x from both sides, and then you get y equals -x minus 2. And from there, you just graph it. So we're going to have y-intercepts at -2 and at 3. So you put 1 point at -2 and 1 point at positive 3. And the slope of the first one is 3 over 2. So you're going to go up 3 and then over 2, up 3 over 2, and then down 3 over 2, down 3 over 2. Okay, and you just keep doing down 3 over 2, down 3 over 2. And then that is one of the graphs. So I'm going to connect those into a line. And then this one starting at -2, that slope is going to be -1. So I'm going to go down 1, over 1, down 1, over 1, all the way to the end. And there's going to be an intercept between the two graphs. So I'm going to connect the dots. And then, as you can see right here, we have an intercept between the two systems. So they intersected at -2 y-intercept is -2, 0. So -2, 0 will be the solution to the system. And then you can also determine that it is an independent function because we only got one solution from graphing that, so it's an independent system. And that is the answer to the first example. So, for when I talked about it being independent, systems can also be, they're not always independent, they can also be dependent and inconsistent. So dependent systems have the same slope. And there is also an infinite amount of solutions for dependent solutions. For inconsistent systems, have the same slope. They have the same slope, but a different intercept, different y-intercept. Usually in inconsistent functions, the lines are parallel. And there is no solution. And then to tell if it's dependent or independent, the independent solutions or independent systems will be like the first example I just went over. So independent systems are when the lines intersect, so both graphs from the system intersect. They will intersect and there is only one solution. select all of these. And they intercepted right here, which means the intercept is 2, positive 1. So once you get the intercept, you have to plug that into the systems to see if it works. So if we plug in 2 and 1 to the x plus 3, or x plus y equals 3, we would get 2 plus 1 equals 3, which is true. So that one works. And then if we plug it into the x, or if we plug it into the x minus 2y, we would get 2 minus 2 times 1 equals 0, which 2 minus 2 does equal 0, but that's not right answer. So, or it does work, so if you plug in 2 and 1, 2 minus 2 is 0, so they're both a solution. They both work, which means that the correct answer is 2, 1, because when you plugged it into these two equations, you came out with the right answer. So the answer to this system is 2, 1, and that is the last example I have. So that's it.